discuss about the topic indefinite integrals basics. Now we want to discuss the basic formulas of indefinite integrals. Integration is a reverse process of differentiation, already we learned in the first year itself. We'll see here derivative of a reverse process of derivative. The derivative is called integration. The derivatives, we'll see the formulas of the derivatives. That is, first of all, derivative of dy dx of x to the power of n is already we have the formula n into x to the power of n minus 1. That is, by using this formula, we can just consider another one more here. This is dy dx of x to the power of n plus 1. Now, derivative consider here. This is using the formula n plus 1 into x to the power of n plus 1 minus 1. That is, n will get n plus 1 minus 1. That is, 1 gets cancelled, x power n will get. That is nothing but from this, let write this, send the derivative right side, it becomes integration. That is, we'll get x to the power of n plus 1 is equals to, we'll get n plus 1 into integral of x to the power of n. That is, we'll get integration of x to the power of n dx is equals to, yes, x to the power of n plus 1 divided by n plus 1. And in generally, in integration, we can consider the integral constant, that is arbitrary constant c. Now we'll go for the one more formula for the integration, dy dx. Let us consider a derivative of the formula, that is, we'll get root x consider is equals to, we'll get 1 by 2 root of x. 1 by 2 root x. That means we'll get here 2 send left side and integration send it, derivative send it right side. We'll get 2 into root x is equals to integration of 1 by root x dx will get dx. That is, we can write the integration formula 1 by root of x dx is equals to, we'll get 2 root of x plus c. This is another one more formula, second formula. Now we'll go for the third formula. Let's consider d by dx of derivative of, we are discussing here kx. We are writing this derivative is nothing but we can write it as k into x differentiation 1. We learnt in the first year. That is, we'll get integral of k is equals to reverse process. We are descending derivative right side, it becomes integration. So we'll get this is kx plus c. That is the next formula. Derivative of d by dx of a to the power of x is equals to e power x. From this, reverse process of differentiation becomes integration. That is, integral of e power x is equals to e to the power of x plus c. Next, dy dx of derivative of, let's consider log x is equals to log mod x is equals to, we can write 1 by x. That is, integration is a reverse process of differentiation. So the integration send it right side, it becomes derivative send it right side, it becomes integration. That is nothing but I'll get derivative of 1 by x is equals to, we'll get log modulus of x plus c. Now then we can proceed another one more formula, d by dx of, we'll get a to the power of x is equals to, we'll get a to the power of x into log x. We know the differentiation, and this is nothing but I'll get integration, reverse process of differentiation is nothing but integration, that is a power x into log a to the power of x into log a, that is once again d by dx of a power x is equals to a power x into log a. This log a send it right side and the derivative send it derivative send it right side, log a send it left side. We'll get here. This is integration of a power x dx is equals to a to the power of x dx is equals to a to the power of x divided by log a will get plus c. Log a plus c. Now then we can proceed second, d by dx of next formula. It is nothing but I'll get trigonometric functions, that is we can write sin x differentiation is, we know that cos x integration is reverse process of differentiation. So send this right side, we can write integration of the cos x is equals to right sin x will get plus c. Just mark out the integration formulas and again read it perfectly. Yes, after this practicing, just once again read out these all the formulas, and again it is useful for the indefinite integrals. Now then we can proceed for the next continuation for the next formulas, that is we'll get here d by dx of differentiation of cos x dx is equals to cos x is equals to, we'll get minus sin x. We know that minus sin x reverse process, so we'll get integration of the sin x is equals to sin x dx is equals to, the minus comes here, that means we'll get minus cos x plus c will get, now integral of the sin x it becomes minus cos x will get, and again next formula d by dx of will get tan x is nothing but we can write it as secant square of x will get, and in reverse process will get secant square of x dx is equals to, we can write it as tan x plus c. Now these are the formulas of the integration trigonometric functions, three formulas. Cot x is minus cosecant square of x, that is integration is reverse process of differentiation, that is will get cosecant square of x dx is equals to, will get minus cot x plus c. Minus cot x plus c, just mark this as a in the box so that we can learn integration formulas perfect. We can go for the next d by dx of will get secant x, that is nothing but will get secant x tan x. Now integration is a reverse process of differentiation, that is will get secant x tan x derivative integration is equals to, will get secant x plus c. Secant x plus c, that is this is we can consider as again standard formula for the integration. Next d by dx of will get cosecant of x, we can take cosecant of x is will get minus cosecant of x cot x, we can write cot x we can take, that is a reverse process of this calculation, that is nothing but cosecant x cot x dx is equals to, will get minus cosecant of x plus c. This is next formula for the integration. Next formula for the integration. Dx of, again after the trigonometric functions we have discussed sin x derivative is sin x derivative, cos x derivative minus sin x, and tan x derivative secant square of x, and cot x derivative minus cosecant square of x, secant x derivative secant x tan x, and cosecant x derivative minus cosecant x cot x. For that, see the integration formulas. Integral of the sin x is minus cos x, integration of the cos x is will get sin x, integration of the secant square x is will get cot tan x, and integration of the cosecant square x is will get minus cot x, integration of the secant x tan x is secant x, and integration of the cosecant x cot x is minus cosecant of x plus c. Every function in integral will get integral constant as it is, it's compulsory will get. And again we'll go for the next set of formulas, that is inverse trigonometric functions. Inverse trigonometric functions. Now that is we'll get first formula of the inverse trigonometric functions, sine inverse of x. Sine inverse of x derivative first is nothing but I'll get 1 by root of 1 minus x square. 1 by root of 1 minus x square. That is, integration is a reverse process of differentiation. That is, 1 by root of 1 minus x square dx is equals to, we'll get sine inverse of x plus c. Sine inverse of x plus c. Then we can go for next formula, dy dx of, we'll get cos inverse of x is nothing but we'll get minus 1 by root of 1 minus x square, minus 1 by root of 1 minus x square, which implies we'll get integration of 1 divided by root of 1 minus x square dx is equals to this minus, send it left side, is nothing but I'll get minus cos inverse of x plus c. See, these two formulas we are getting for the same function. That means we can write it as this, we can write it as minus cos inverse of x plus c. This is, we can derive in another method also, we'll get in the from inverse trigonometry, sine inverse x plus cos inverse of x is equals to, we'll get pi by 2. That means we'll get sine inverse of x is equals to minus cos inverse of x plus pi by 2. Just replace in the sine inverse x plus replace, that is minus cos inverse x plus pi by 2 plus c we will get, that is the integral that merges into the integral constant. And that is nothing but we'll get every function we are getting sine inverse x, we can replace it by minus cos inverse of x, cos inverse of x. In option, depends on the option answer or answers object answers, we can choose this function. Go for the next formula, d by dx of tan inverse of x. That is, we'll get derivative of tan inverse of x is 1 by 1 plus x square. That is, reverse process of differentiation is integration. That means I'll get 1 by 1 plus x square integration is equals to, we'll get tan inverse of x plus c, or we can get this in conversion, we'll get minus cot inverse of x plus c. In previous formula also we observed these tan inverse of x we can write using the inverse trigonometric formula, that is tan inverse of x plus cot inverse of x is equals to pi by 2. That is, change the tan inverse of x is equals to minus cot inverse of x plus pi by 2. We can write, replace in the place of tan inverse, it becomes minus cot inverse of x plus integral constant some other k will get. Now let we go for the next formula, that is nothing but the derivative of secant inverse of x. Let's consider here, this is nothing but 1 divided by modulus of x into root of x square minus 1. That is, integration of this formula we can write integral of 1 by mod x root of x square minus 1 dx is equals to, we'll get secant inverse of x plus c, or we can write minus cosecant inverse of x plus c as the same previous form. Yes, understood this one. Go for the discussion of the hyperbolic functions. The derivative of the hyperbolic function, that is first of all sine hx. We learned in the first year sine hx derivative is nothing but I'll get cos hx, that is integration of the cos hx dx is equals to, we'll get sine hx plus c. Sine hx plus c. Now then we'll go for the next formula. D by dx of derivative of cos hx dx is equals to, we'll get sine hx, will get sine hx. Derivative of the cos hx is sine hx. Now integration of the sine hx dx is equals to, we'll get the reverse process cos hx plus c. This is next formula. And then we can proceed for next one. D by dx of we'll get tan hx is equals to, we'll get secant square of h square of x, will get secant h square of x, we can write. And integration of the, yes, reverse process of derivative is nothing but I'll get integration of, we can write secant h square of x dx is equals to, we'll get tan hx plus c, tan hx plus c. Now then we can proceed. Derivative of, we'll get d by dx of derivative of cot hx is equals to, we can write it is minus cosecant h square of x d, will get, which implies integration of cosecant h square of x dx is equals to, will get, reverse process is nothing but minus cot hx plus c. This is next formula of the integration. Now then we can proceed. D by dx of derivative of, will get, yes, next secant x dx is nothing but secant hx is equals to, will get minus secant hx tan hx will get, the reverse process is nothing but I'll get integration of the secant hx tan hx dx is equals to, will get secant hx plus c. This is next formula for integration. And then we can proceed the formula. D by dx of, we can write it is cosecant hx is equals to, will get minus cosecant hx cot hx, will get cot hx. The in reverse process will get the integration of the cosecant hx cot hx dx is equals to minus cosecant hx plus c. This is the next formula in integrations. Once again, once observe here, in the differentiation hyperbolic and trigonometric, here cos hx derivative in trigonometric function will get minus sin x. Cos hx derivative, cos x derivative will get minus sin x will get, but in hyperbolic the derivative of the cos hx is plus sin hx. Once again here, trigonometric function cos x derivative is minus sin x, but hyperbolic function cos hx derivative sin hx. And next one more difference is, we'll get here, this is derivative of secant hx is equals to, we'll get the derivative of secant hx is minus secant hx tan hx. That is in trigonometric function, in the trigonometric function, derivative of secant hx we got there, the only secant x tan x will get, secant x tan x. That is, we get opposite signs for these formulas. This is one formula and this is another one more formula. We need to remember these formulas. In the integration also there will get trigonometry and hyperbolic, only these two are some difference will get. The integration of the sin hx, integration of sin x is minus cos x and integration of the sin hx is plus cos x in the hyperbolic and trigonometric. And in the hyperbolic we got secant hx tan x integration, we are getting this is a minus secant x will get, and again in the trigonometry plus secant x will get, in the trigonometric will get plus x secant x. This we need to remember. These two are very very important rememberings. We need to remember these two formulas. Dx of sine inverse hyperbolic function. Sine inverse hyperbolic function, that is sine h inverse of x, is already we know that 1 by root of 1 plus x squared. That is a reverse process of differentiation is integration, that is 1 by 1 plus x squared dx is equals to, we'll get here sine h inverse of x plus c, or we'll get log of, we'll get x plus root of x square plus 1 plus c, we get log of x plus root of x square plus 1 plus c. Then we can proceed next formula, d by dx of derivative of, we'll get yes, cos h inverse of x is nothing but I'll get 1 by root of, we'll get x square minus 1, which implies reverse process of differentiation is, we'll get this is square root of, we'll get x square minus 1 dx. Here the domain of the cos h is under root function. In the function we lent a root f of x defined for, we'll get x square greater than 0, that is x square greater than 1 will get mod x greater than 1, which implies domain is x belongs to, will get minus infinity to minus 1 union, will get 1 to infinity, will get this is the domain of the cos h inverse of x. That is, here there are two cases will get. One case is for x greater than 1, we can write cos h inverse of x plus c, and for x less than minus 1 will get minus cos h inverse of minus x plus c. There are two cases we need to remember. Then we can proceed d by dx of derivative of, will get tan h inverse of x is equals to 1 by root of, will get 1 minus x square, that is reverse process is nothing but will get reverse process of 1 by 1 minus x square dx is equals to, we can write tan h inverse of x plus c. Now see here, this is this hyperbolic inverse cos function in logarithm terms, x plus root of, will get x square minus 1 plus c. Yes, now this is one formula we need to remember, and again this is another one more formula. Next we need to proceed to remember these formulas. These are the inverse derivatives of the inverse hyperbolic functions. Right? Of the f plus g of x dx is equals to integral of the f of x dx separate, integral of the g of x dx separately, we can write. Next we'll go for the next same in the same process, f minus g of x dx is equals to integral of f of x dx minus integration of the g of x dx. Then we can proceed integral of the k into f of x dx is equals to, we can write k into integration of the f of x plus c. Now then we can proceed the formula. We can write here some of examples related to these applications of the integrations. First example 1, let's consider 2 into x to the power of 7 dx. We can proceed. Now k into f of x, same as this model. We can write k outside, that is 2 outside, and integration of the x power 7 dx. Now then we can write here using the formula, integration formula. First formula of integration, x power n dx is equals to x to the power of n plus 1 divided by n plus 1 plus c. That is, we'll get 2 into x to the power of 7 plus 1 divided by 7 plus 1 plus c. That means we'll get 2 into x to the power of 8 by 8 plus c. 2 ones are 2 fours are. The final answer we can write x to the power of 8 by 4 plus c. This is one only. Integration of x to x root x dx. We can proceed. This is, we can simplify, that is x to the power of 1 into x to the power of 1 by 2. Bases are equal, power should be added, that is 1 plus 1 divided by 2. That is, we can write as x to the power of 3 divided by 2. That means this we can write it as k outside the integration and x to the power of 3 by 2. After simplification we got, that is integral of x to the power of 3 by 2. This is just an application of the integration of x to the power of n dx is equals to integral of x to the power of n plus 1 divided by n plus 1 plus c. This is the next, the application of the next formula. Now here this is 2 into x to the power of 3 by 2 plus 1 divided by 3 by 2 plus 1 plus c. We can by using the formula, that is we'll get 2 into x to the power of, on taking LCM, 5 by 2 divided by 5 by 2 plus c. That is equals to, we'll get, this is 4 divided by 5 into x to the power of 5 by 2 plus c. Now this is next, we can proceed another one more question on the same model. Let's consider here, this is a third, fourth question. See that again same application, that is we'll get integration of the f plus g is nothing but integration of f plus integration of g. So this is subtractions also same, separately we can split in the same manner, that is integration of x cube minus constant, write it outside, integration of x square will get plus integration of the 3 dx we got. That means we'll get, this is x cube integration using the same formula, x to the power of 3 plus 1 divided by 3 plus 1 will get minus 2 into x to the power of 2 plus 1 divided by 2 plus 1 plus 3 into x to the power of x power 1 by 1 plus will get. Now from the calculation here, x to the power of 4 by 4 minus 2 into x to the power of 3 divided by 3 plus 3x plus c. Now this is the result of the next question, and we can proceed for this next question number 5. Integration of the x plus 4 by 1 plus x square dx is, we can write x plus will get 4 into this, separately write integral of 1 by 1 plus x square dx, fx integration separate and gx integration separate. So x integration, x power 1 integration, x power 1 plus 1, 2 divided by 2 plus 4 we are writing outside, 1 by 1 plus x square integration. Already we have the formula 1 by, yes, integral of 1 by 1 plus x square dx is nothing but in the inverse trigonometric functions integration we learnt. This is the formula. Just write the formula directly, yes, plus c. This is the integral of e to the power of 2 log x dx. Now to solve this, first consider e to the power of 2 log x, simplify it, e to the power of 2 log x, simplify it. Now that is, I'll get this just in the form of n into log a is equals to log a power n. That is, apply the formula, log of will get x to the power of 2 we get. That is again to the base e, nothing is given in logarithm, means we can consider natural logarithm, base e. Now then we can proceed here using again one more formula, log of will get a to the power of log x to the base a is equals to x using the again one more formula. Bases are equal, logarithm should be removed, so that is nothing but x will get, that is I will get here, this is same basis we got, that is nothing but will get x square will get. In the same way, this simplification using that we can write x square. X square just in integration formula we can use it, integral of x to the power of n dx is equals to will get x to the power of n plus 1 divided by n plus 1 plus c. That means we can write this as x to the power of 3 divided by 3 plus c. We can write. This is the answer. And then we can proceed for the next question. Integral of x cube minus cos x plus 4 divided by root of x square plus 1 plus dx is, we can go for this question. See this question, integration of f plus g or f minus g. We can write the separate integrations x to the power of 3 minus integral of cos x will get plus k constant outside integral of 1 by root of x square plus 1 dx will get. Now see this x power n model, integration of the x power n, just we have already completed x to the power of n plus 1 divided by n plus 1. That means we'll get x to the power of 3 plus 1, that is 4 by 4 is the result. And one more application, this integration of the cos x in the trigonometry, integration of the cos x dx is equals to, we know that sin x plus c, that is nothing but we can write it as this integration is sin x, and 4 into 1 by root of 1 plus x square, one more formula, 1 by square root of will get x square plus 1 dx is nothing but will get, it is directly sin h inverse of x, sin h inverse of x. So this is will get sin h inverse of x plus c. This is the result of the question. Now then we can proceed for the next question. See this next question, integral of 1 divided by cos hx plus sin hx dx, cos hx plus sin hx dx. Now just in the hyperbolic functions we know the formula cos h square of x minus sin h square of x is equals to 1. In hyperbolic functions, cos h square of x minus sin h square of x is equals to 1. Using that, just to get the cos h square x minus sin h square x, that is nothing but we'll get a square minus b square is there. That is, we can split into a minus b into a plus b. The result is 1. So to just rationalize it, rationalize the opposite to get the convert into the result form. That is nothing but I'll get cos hx plus sin hx. Now we are multiplying with the numerator cos hx minus sin hx, and again denominator is cos hx minus sin hx, cos hx plus sin hx into will get cos hx minus sin hx. We're multiplying and dividing with numerator and denominator. That means we'll get in numerator we got cos hx minus sin hx we got. In denominator, a plus b into a minus b, a square minus b square will get sin h square of x we got. Cos h square x minus sin h square of x is, already we have the result. Yes, cos hx minus sin hx divided by, this is 1, on separating will get, this is nothing but integral of cos hx is, we know, sin hx, integration of the sin hx we know that cos hx plus c. Yes, these questions integral of 1 plus cos square x divided by 1 minus cos 2x. In the derivative, we have the formula u by v, derivative of u by v, we have that derivative of dy dx of u by v is, we'll get u dash v minus u v dash divided by v square. But integration, we doesn't discuss the formula of u by v and uv. uv is in further we can learn as a by-parts rule form. U by v, it is not solvable. We can simplify, and again we need to get in the functions, separate functions form. Then after that we need to integrate. Now let us consider here in this we need to split as a separate functions. Separate functions means minimize or just convert this into the single term form. That is nothing but I'll get 1 minus cos 2x will get as a 2 sine square of x, and in numerator we'll get cos square of x as it is. Now divide this term individually. That means we'll get 1 by 2 into sine square of x will get, and this is cos square of x divided by 2 sine square of x. We divided 1 with a separate, cos square with a separately. Now here see this calculation, 1 by 2 into 1 by cos square is nothing but we can write it as cosecant square of x will get, and again this is nothing but will get 1 by 2 into will get this is a cot square of x integration. Cot square of x integration. Now see this 1 by 2 into integration of the cosecant square, or we have the formula minus will get cot x plus c, we know that, and cosecant square x, cot square x, we doesn't have the formula. We have only the formula for the integral of the cosecant square of x dx is equals to, we know that, minus cot x plus c, but we don't have the formula for the cosecant square. Convert this cot square using the trigonometric formula. Cot square we can write it as a cosecant square of x minus 1, replace it, that is 1 by 2 into integral of, using the trigonometric formula, cosecant square of x minus 1 by 2 dx. Now this is minus 1 by 2 into cot x plus we'll get 1 by 2 into, this is nothing but minus cot x, and again this one integration is nothing but x will get plus c. These are next the solution of this equation. And then just we go for the next question solving, that is ninth question solving. The same way denominator we need to simplify to get into the addition terms model, that is rationalize the denominator, that is nothing but multiply with 1 minus cos x, and numerator and denominator 1 minus cos x into 1 plus cos x, a plus b into a minus b, a square minus b square, that is 1 square minus cos square x will get. Now here 1 minus cos x divided by 1 minus cos square becomes sine square of x will get sine square of x. Now from this we can proceed this integral of 1 by sine square separately divided, 1 by sine square will get separate, sine square of x separate, and cos x divided by sine square of x will get separately. This is nothing but 1 by sine square of x, we can write it as it is a integral of cosecant square of x will get minus, this is nothing but cot x cosecant or cosecant x cot x. Cosecant x cot x, these are direct formulas of the integration. Cosecant square integration will get minus cot x minus cot x, and cosecant x cot x integration minus cosecant of x plus c, minus and minus becomes a plus. Now we go for the next question. Next question, that is the 10th question, we'll solve. See this here, 10th question. Integration of the 1 divided by sine square of x into cos square of x. We'll discuss this question. This is also same 1 by f of x form given in the question. Let us see this question. It is directly cosecant square into secant square will get. Product of the two functions will get. Product of two functions, we doesn't know the formula. Derivative we have, but integration till now we discussed. So this we need to separate into the addition of the two functions form. That is, to separate into addition of two functions means one write as in the form of sine square x plus cos square of x using the trigonometric identity. That is, I'll get sine square of x into this is cos square of x in denominator. Now split as a two separate function form. Sine square x separate divided by this denominator separate. Cos square x divided by the denominator separate. That means integral of will get sine square of x divided by sine square of x into cos square of x separate, and cos square of x divided by sine square of x into cos square of x dx separate. These and these gets cancelled. Cos square gets cancelled. 1 by cos square, it becomes a secant square of x dx will get, and this is cosecant square of x dx will get. That is, secant square integration is will get tan x will get, cosecant square integration will get minus cot x plus c. This is the final result of the 10th question.